Let us finish up the presentation of CSEC Multiple Choice Practice Paper 7 with Part D. Part D has the final section of 15 problems ranging from problem number 46 to problem number 60. Each of the letters of the word chance is written on a strip of paper and one strip is randomly drawn. What is the probability of drawing a letter C? Chance. Probability of drawing a letter C. To find the probability, we divide the number of events that will give a favorable outcome by the total number of events. Any C will give a favorable outcome. We have two occurrences of that letter, there and there. Two occurrences will give a favorable outcome. Now we need to divide that by the total number of equiprobable events. Because of the context of the problem, it is not unfair to say that we have 6 letters. Nevertheless, it is not really correct to say that because C is actually one letter that has 2 representations. We may therefore say that we have 6 representations of letters. This represents the number of events. So, it is not 100% correct to say that we have 6 letters, but that we have 6 occurrences of letters. And we have no doubt 2 occurrences of the letter C right there. So 6 will be the total number of events that will give a favorable outcome. Therefore 6 is the number of equiprobable events. The fraction may be reduced by a common factor of 2. So 2 into 6 is 3 and 2 into 2 is 1. The correct answer is option C, 1/3. To remove the ambiguity about number of letters as opposed to number of occurrences of letters, we may make reference to the number of strips of paper instead. There are a total of 6 strips, 2 of which have the letter C written on them. So that is another way out, although we are sure that we are not talking about necessarily letters, but the total number of events that will give a favorable outcome as opposed to the total number of equiprobable events. The highest weekly wage of a group of employees is $105.40. If the range of the wages is $27.50, how much does the lowest paid employee receive? By common sense, we may just look at it and know exactly what to do with this problem. Any candidate who is prepared to use common sense will just subtract the range of wages from the highest wage. No problem with that. So we have the highest wage and we subtract the range of wages. The result is the lowest wage. The correct answer is option B. Arriving at the correct answer needs only one step in subtraction and need not be more time consuming than necessary. Just one step of subtraction and we are done. So we are highlighting 10 and 2. In the end, we imagine that we need to subtract 2 from 10. But do not forget that the 7, that is the number trailing 2. So we have 7 is the number that is trailing 2. Is greater than 5. That is the number that is trailing 10. Therefore, the subtraction will require a renaming of 10 that we have here. We therefore subtract 2 from 9 and the result is 7. The correct answer has to be the one that begins with a 7. So this is our correct answer. Well, we are just taking advantage of the fact that in a multiple choice problem the correct answer is there. So all we need to do is identify the correct answer, and that does not require a microscopic term by term subtraction of one number from the other. If we can use our common sense and make a single subtraction, then we may be able to identify, because identifying an answer is different from arriving at the answer. So we may be able to identify the answer without actually arriving at it, and we may do that with just one single step of subtraction. Alternatively, we may use the statistical fact that the range is the difference between the largest and smallest number in a data set. So that is a fact. The range is the difference between the largest and smallest number in a data set. So the range is equal to largest minus smallest. If we use transposition and make the smallest, because we need to determine the lowest paid employee, the amount or the wage of the lowest paid employee. So we need to determine from this expression an expression for the smallest. Consequently, by making a substitution, we may arrive at the smallest wage. So the smallest is equal to the largest minus the range by transposition. The process of transposition used range that is positive on the left hand side. When we transpose, we will have it negative on the right hand side, and the smallest that we have here that is negative on the right hand side will be positive on the left hand side. Making the simple substitution and finally making our subtraction, we get 77.9 or $77.90. The bar chart shows ages of children who took part in a survey. How many children took part in the survey? Number of children is on the vertical axis. This means that the height of each bar tells us the number of children in each category. To find the number of children that took part in the survey, we need to add the numbers that represent the height of the bars. So we are saying that since we need to determine the number of children that took part in the survey, we need to be mindful of the fact that number of children are on the vertical axis, and in order to find the total number of them in the survey, we need to find the number that is associated with each category, and we need to add those numbers. And we are going to make reference to the vertical axis like so. So for the first one, we have 3 children. Then in the next category, we have 4, and so on. 2, 5, 1. 15. The correct answer is option D. When we have a string of numbers that we need to add together, it may be very convenient to take pairs of numbers whose sum end with a 5 or 0 as follows. So in adding, sometimes it is not good to just look at the left and just add to the right. We may identify pairs of numbers that add to give value that end with a 5 or a 0, like so. 3 plus 2 is equal to 5. 4 plus 1 is equal to 5. And then we have a 5 right there. And when we add them, we get 15. There's nothing to it. However, in this particular case, it might not be necessary to make use, when the numbers are very large, then we can see that the effect of doing this may cause the problem to be a lot easier, but not necessarily in this particular case. I'm just using this particular case of a demonstration of that principle that may be applied when the numbers are more cumbersome. Always keep an open eye and an open mind. Life is easier for those who are prepared to think. The lengths of 15 cabbage leaves were measured to the nearest centimeter, and the information grouped as shown in the table. The beginning and end points of the class interval of 10 to 14 are, so we are saying that the lengths of 15 cabbage leaves were measured to the nearest centimeter. From you hear that word, the nearest, you know that that is an indication of some rounding off. So to the nearest centimeter, and the information grouped as shown in the table. The beginning and end points of the class interval of 10 to 14 are, what is the beginning and end point of that class? 10 to 14. Measured to the nearest centimeter. All measurements are given to the nearest centimeter. This gives the impression of some amount of rounding off. If 10 represents a rounded figure, the smallest value capable of being rounded to 10 is 9.5. This will represent the lower bound. Therefore, either of options B and C is correct. So we have identified the lower one right here to be 9.5, and that is represented by option B or option C. What about the upper one? Normally, if 14 represents a rounded figure, we expect that the largest value capable of being rounded to 14 is 14.4. Considering the first decimal place, we do not say that because 14.5 is the nearest answer in the options, option C has to be correct, although it is. So although C gives the one nearest to 14.4, which is 14.5, it is correct. We are not saying that it is correct because it is the nearest one, although it really is. Boundaries involve a little more than rounding off. So we are sure that C is correct. But we are saying boundaries represent a little bit more than rounding off. In statistics, a boundary is shared between two consecutive classes. They are calculated by taking the average of the upper boundary of a particular class and the lower boundary of the subsequent class. So the upper boundary of a particular class and the lower boundary of the subsequent class, the average of those two. There we have 14 plus 15 divided by 2, and the result is 14.5. We may also say that the boundary is the average of the lower boundary of a particular class and the upper boundary of the previous class. A boundary belongs to two classes, being the upper boundary of one class and the lower boundary of another. A class boundary is so chosen that it represents the halfway point between the two class limits, and that is the greatest thing that we need to consider when we are calculating boundaries. A class boundary is so chosen that it represents the halfway point between the two class limits. So it represents the upper limit of a particular class and the lower limit of the subsequent class. So it is the average of the upper limit of a particular class and the lower limit of the subsequent class, or the average of the lower limit of a particular class and the upper limit of the previous class. That round figure that pertains to classes are boundaries and not typical rounded figures. The round figure that pertains to classes are boundaries and not typical rounded figures. Usually, the classes are of equal size. Calculating boundaries from limits preserves the size of the classes and also causes them to be uniform relative to each other. The lower boundary of the first class is calculated as if there is another class previous to it, and the upper boundary of the final class is calculated as if there is another class subsequent to it. We may also use the fact that the boundaries are a sequence of numbers, or that they are always half of a unit away from the limits. So there are quite a few things that we may consider in determining boundaries. So if we have a boundary here, 9.5, then we have 14.5, then the other one will be 19.5, and we will see that they are increasing by 5 each time, so they are in sequence. Also, that the boundary is usually half a unit away from the limit. So half a unit away from 14 is 14.5, and half a unit away from 15, if we go in this direction, because we are talking about the lower boundary in this particular case, also is 14.5. So 14.5 is half a unit away from 14 and half a unit away from 15. So that is another thing that we may consider. As we said before, that rounded figures that pertains to classes or boundaries are not typical rounded figures. A boy throws a die twice. What is the probability that he will get a 3 followed by an even number? So throwing a die twice, what's the probability that he will get a 3 followed by an even number? Finding the probability of getting a 3 followed by an even number is the same as finding the probability of getting a 3 and an even number. The probability and is found by multiplication. Our first duty is to find the probability of receiving a 3, then the probability of receiving an even number. The probability that an event will occur is equal to the total number of events that give a favorable outcome divided by the total number of equiprobable events. To find the probability of receiving a 3, there is only one 3 on a die. So the total number of events that will give a favorable outcome is 1. We will divide this by the total number of equiprobable events. This is equal to 6, since the die has 6 faces and consequently 6 numbers. So 1 event out of 6. So 1, 3 out of a total of 6 numbers, and that is our probability. That will be multiplied by the probability of receiving an even number. There are 3 even numbers and a die. The total number of events that will give a favorable outcome, that will be multiplied by the probability of receiving an even number. There are 3 even numbers and a die. The total number of events that will give a favorable outcome, that will be multiplied by the probability of receiving an even number. There are 3 even numbers and a die, which is the total number of events that will give a favorable outcome. This will be divided by 6, and 6 we know to be the total number of equiprobable events. So 3 out of 6, 3 6. Let us take a look at it on the other slide. 1 6 multiplied by 3 6, and we may reduce by a common factor of 3. 3 into 6 is 2. 3 into 3 is 1. We have 1 over 12. And that is the answer. That is represented by option A. The correct answer is option A. Instead of going all the way, reducing the fractions, we could have made use of the fact that 3 out of 6 is a half and multiply that half by 1 over 6. So 3 out of 6 is a half. Multiply that by 1/6, we get 1/12. The pie chart shows the preference of drinks of a group of students. If 12 students prefer chocolate, then the total number of students in the survey is what we need to determine. And we may just use common sense and sum this up, getting the answer in one step. The problem may be solved mentally by first considering that the angle associated with chocolate is supplementary to 120 degrees. Supplementary angles add to give 180 degrees. So that angle is supplementary to 120 degrees. It is therefore 60 degrees. There are 6 occurrences of 60 degrees in the entire revolution of 360 degrees. The entire pie will be represented by 360 degrees. The one associated with chocolate we know to be 60 degrees because of this straight line that we have right here. This straight line tells us that this angle that comes around here is 180 degrees. So if this is 120, then this is 60. So 60 degrees is the angle represented by chocolate, and the entire revolution is 360 degrees. Therefore, we have 60 degrees, 360 degrees. In order to arrive at this 360 degrees, we need to multiply this by 6. So 360 degrees is 6 times 60 degrees. That means the total number of students in the survey is 6 times the number that prefer chocolate. So chocolate is associated with 12 students. Therefore, the total number of students must be 6 multiplied by 12, which is equal to 72. The correct answer is option B. On the next slide, we will take the approach of a candidate that is not prepared to just take a look at the problem and figure out the answer. So we could have just looked at it, figure out the answer. 120, straight line. This is 60 degrees. 60 degrees is 1/6 of the entire pie. Therefore, if 12 students are here, and that is represented by 1/6, we need to multiply that 12 students by 6 in order to determine the number of students in the entire survey, because the entire survey, which is the entire pie, is represented by 360 degrees. 60 degrees into 360 is 6, so we need to multiply that 12 by 6. The result is 72. The result is 72. In order to solve this problem, we need to take the 12 students that prefer chocolate and associate that with a particular angle in order that we may find the number of students associated with the entire pie. And the entire pie is represented by 360 degrees. The angle associated with chocolate is on a straight line with 120 degrees. Angles on a straight line add to give 180 degrees. The remainder is the angle associated with chocolate, 60 degrees. From here, the answer may be determined mentally. However, we will use ratios in solving it by considering that 12 students are associated with an angle of 60 degrees. And the total number of students that we do not know, which we will call x, is associated with 360 degrees. There we have it. Instead of converting the ratios to fractions, we may see that 360 is 6 times 60. So this is 6 times this, therefore this must be 6 times this. As easy as that. Therefore, x must be 6 times 12 in order that the correct proportions are maintained. The correct answer is option B. AC and DE are straight lines intersecting at B. Angle DBA is equal to 58 degrees as shown right here. The measure of angle ABE, which is this one, that is the one that we are attempting to find, the angle ABE. The angle that is given and the one that we seek are angles on a straight line and will add to give 180 degrees. Angles that add to give 180 degrees are called supplementary angles. So they are supplementary angles that add to give 180 degrees are supplementary angles. So ABE plus DBA is 180 degrees and one is 58. The other is the difference between 180 degrees and 58 degrees, which is 122 degrees. The correct answer is option C. We may go to Australia and back in solving the problem. Let us take a look at that on the next slide. So apart from the fact that we know that angles on a straight line are to give 180 degrees, this angle and the one that we are seeking are to give 180 degrees. This one is known, so the other is the rest of 180 degrees. Turns out to be 122 degrees. So let us go to Australia and back. We will now consider that at the intersection of two straight lines, opposite angles are equal. CBE is equal to ABD. That one. And also that the other two angles are equal. So the sum of the angles in an entire revolution is 360 degrees. Let us subtract the two angles of 58 degrees each. So we are sure that for intersecting lines like this, these two angles are equal. So we are sure that these will give a sum of 116 degrees, and we will subtract that from the angle of an entire revolution. That is 240 degrees. That is what the result will be. Now that will be the sum of these two angles. So the other two angles are opposite to each other and are also equal. After subtracting the two angles of 58 degrees from 360 degrees, the remainder will be shared equally between the other two angles. So 244 is left. We will share that equally between the other two angles, and that will give us 122 degrees. This confirms that option C is actually correct. We have chosen to use two principles. What are the principles? Angles on a straight line have a sum of 180 degrees. And what is the other one? Opposite angles on two intersecting straight lines are equal, along with the fact that the angle of an entire revolution is equal to 360 degrees. So in the first case, we use the fact that angles on a straight line are to give 180 degrees, and in the second case, we use the fact that 1. Opposite angles are equal, and also that the entire angle of a revolution is equal to 360 degrees. AC and DE are straight lines intersecting at B. Angle DBA is 50 degrees. Which of the following angles are equal? When we have intersecting lines, as we do in the diagram, opposite angles are equal. Opposite angles and therefore equal angles will be marked with the same color. So red for those two that are equal, blue for those two that are equal. Any pair among the options that is the same as any of the pairs of marked angles is the correct answer. The correct answer is option D. So option D has ABD, ABD is equal to CBE, CBE. These two are equal. Option D is correct. The translation by which AB is mapped to A prime B prime is represented by which one of these? Translation vector, vector of translation. The matrix of translation is a column vector that is added to each of the points that is to be transformed. The statement may be represented by the simple equation. So let us represent that. The matrix of translation is a column vector that is added to the point that is to be transformed. So this is the vector that is added to the point that is to be transformed, and the result is the image A prime. There we have the vector V being added to the point A, and the result is the image of A that is given as A prime. The expression may be transposed, resulting in an expression for the vector V. Therefore, if we need to find the vector of translation, we use the principle that we have right here, that a matrix of translation is a column vector that is added to each point that is to be transformed. So add the vector to the point that is to be transformed, and we end up with the image. Therefore, in order to determine the vector, we just transpose and we have the image minus the original. The expression may be transposed, resulting in an expression for the vector V. So now that we have that, using A and A prime as we have them in the diagram, we may calculate the vector V. So 4, 6 minus 2, 5, the result is 2, 1. The correct answer is option B. It is important to note that in the calculation, not the point themselves but their position vectors are used. And it is also important to note that the vector V is equal to 2, 1 may be obtained by using B prime 7, 8 and B 5, 7. As a matter of fact, after finishing the calculation with these 2 points, we may use that as a verification of the correct answer, or that the one that we have here is correct, because in a translation the relationship between points and their images are always the same. If we add the translation vector 2, 1 to 2, 5, we will get 4, 6. And if we add it to 5, 7, we will end up with 7, 8. The point A is shown on the diagram. What are the coordinates of the image of the point A under a reflection in the y-axis? So reflect that point in the y-axis. How do we do that? The point is to be reflected in the y-axis. The line joining a point to its image must be perpendicular to the mirror line, and the point and its image must be equal distance from the mirror line. Since the mirror line is vertical, which is the y-axis, a vertical line, any line that is perpendicular to it must be horizontal. The point is 4 units to the right of the mirror line, which is the y-axis. Its image will therefore be 4 units to the left of the mirror line. Right, and that point is negative 4, 3. The correct answer is actually option A. The line joining the point and its image will be horizontal. There will therefore be no change in the y-ordinate. So, one tip that we could have used, we could have just looked at this and say A is the point 4, 3. Because under reflection, the movement is horizontal, then the answer in which the y-ordinate remains the same is correct. So we could have taken a look at it and write the answer down without having to go through all of this. The only answer, or the only option that has 3 is the correct answer, and that is option A. Because since there is no vertical movement, then the vertical ordinate will be preserved in a reflection in the y-axis. So we just look at this and we're able to tell the answer without going through all of this. Triangle LMN is rotated anticlockwise about L through 90 degrees. Which of the following is its likely image? In solving problems in mathematics in particular and life in general, it is wise to use things that are convenient to you. We may therefore consider the horizontal line LN in the original object because it is easy to see the result of rotating it through 90 degrees anticlockwise about L. So if we use this horizontal line, rotate it anticlockwise about L, it is going to be vertical. It's as easy as that. After rotating it through 90 degrees anticlockwise about L, it will be vertically above its initial position. So it will be like that. Do we have any vertical? Yes, we have 2 of them. This one is vertical, this one is vertical. Which one is the correct answer? Going in a clockwise direction, the point M will be ahead of the line LN. Its position relative to the line LN will be as follows. So N, if we are going in a clockwise direction, M is leading the line LN. Therefore, N will continue to be leading after the rotation like that. The one in which the relative positions of the line and the point are similar to our little demonstration is option B. And that is the correct answer. Apart from that, we may take a look at what a real rotation through 90 degrees anticlockwise about L will actually yield. So do the actual rotation. And what do we see? 90 degrees rotation. Do it again. 90 degrees rotation. That is it. And which one? Option B is correct. Now that you have seen, you have believed. Blessed are those who, in the weight of adequate evidence, have believed. In the figure, the line CD is the image of AB after which one of these transformation? A rotation through 90 degrees, center O, which is the origin, an enlargement of scale factor -1, a translation by the vector -4, -3, a reflection in the y-axis. Apart from the fact that if a rotation is to be completely described, then the direction clockwise or anticlockwise must be given. The transformation cannot represent a 90 degrees rotation. we will demonstrate this on a subsequent slide. So apart from the fact that if we are describing a rotation completely, then we need to have included the direction, whether anti-clockwise or clockwise. That is not there. But apart from that fact, we will demonstrate that this cannot be a 90 degrees rotation at all. Also, for an enlargement or any size transformation, it cannot have a complete description without a center. There is another property of a size transformation with negative scale factor that is not present. So there is another property of an enlargement with a negative scale factor that is not present here, apart from the fact that if you are going to give an enlargement irrespective of the scale factor, then the center of enlargement has to be included, without which that is not a full description of an enlargement. A translation is the easiest transformation to identify. In a translation, an object and its image are the same in all respects. The only difference is in their locations. That is not true for the lines in the diagram. They are not the same in all respects. Therefore, we are sure that that one is not a translation. By a process of elimination, option D is correct. Not only that, but the location of the points are true to the principle that the line joining a point to its image is perpendicular to the mirror line and the points are equal distance from the mirror line. So apart from the fact that by elimination we are sure that option D is correct, apart from that fact, we are sure that in the diagram that we have there, the principles of reflection are adhered to, which are the line joining a point to its image is perpendicular to the mirror line, which is 1, and the point and its image are equal distance from the mirror line. The y-axis is the mirror line. It is vertical. The horizontal lines of the grid are therefore perpendicular to it. Let us now consider the distances of the points and their images from the mirror line, because no difficulty in this. The mirror line, or the proposed mirror line, is the y-axis. The lines that are perpendicular to the mirror line are these lines that we have on the grid right here. Therefore, we have no difficulty seeing that a line joining a point to its image is perpendicular to the mirror line. All we need to do now is show that the distances are equal. That is, the distance of B from the mirror line is the same distance as D, which is the image of B, from the mirror line. So that does it, and also that the distance of A from the mirror line is equal to the distance of C, which is the image of A, from the mirror line, and that also does it. So we are sure that we have there a reflection. The distances that we desire to be equal are equal, and there is no doubt that the vertical mirror line is perpendicular to these horizontal lines on the grid. That's all there is to it. The distances are equal. D is correct. Let us insert a point on the grid. Which one of the transformation are we looking at now? Let us insert a point on the grid. Write down its coordinates, 2, 3. Rotate the point 90 degrees clockwise about the origin. 90 degrees clockwise about the origin. And what do we know? Write down the coordinates of the image. So we have the point 2, 3, and we rotated it 90 degrees about the origin. Neglecting this sign, notice how the values exchange places. That is always a property of a 90 degrees rotation. The values exchanging places is always a property of a 90 degrees rotation about the origin. Do an anti-clockwise rotation and the result will be similar. Let us insert a point on the grid. Here's our point. Write down its coordinates. Then what do? Rotate the point 90 degrees anti-clockwise about the origin and see what happens. Write down the coordinates of the image. And what do we know? Neglecting the sign, irrespective of the direction of rotation, we still have an exchange of places in the values. Like that. And that is always a property of 90 degrees rotation about the origin. The transformation is not a 90 degrees rotation about the origin if there is no exchange in the values of the coordinates, and that we did not have in the setup that we had on the previous slide, in which we were required to tell if the line that we have there is an image of the other one under any form of 90 degrees rotation. What do we do now? Let us see what happens during a translation. So there we have a translation. After translation, the only difference between the line and its image is that they have different location. They are parallel, they are the same length, they have not twisted, they have not turned. They are the same. And that is not true for the setup that we had, that we required to identify the transformation associated with it. After a translation, a line and its image are parallel to each other. Now, this one, we are putting under the microscope also the one for the enlargement with a negative scale factor. For an enlargement or any size transformation that has negative scale factor, the image is formed on the opposite side of the center. Therefore, lines joining points and their images will cross at the center of enlargement under a negative scale factor. During the process, each point will travel along a straight line from its original location through the center by a distance determined by the scale factor. In this particular case, the scale factor is -1. The distance of the original point from the center will be multiplied by 1. So the distance is the same, which is 1, and the scale factor means that it will be formed on the opposite side of the center of enlargement. So the center is the origin in this particular case. That point goes there. It's by the same distance, and that is the image of A. B goes there through the origin, and that is the image of B. So what do we know? If we have a size transformation by a negative scale factor, what will happen? There is a point at which the line joining points to their images will cross. For a size transformation with negative scale factor, there is at least one point where lines joining points to their images must cross. And in this particular case, of course, we know that that single point is actually the center of enlargement. But in the previous occasion, or for the transformation, or for the diagram that we were analyzing, that was not the case. In the figure, the line CD is the image of AB after which one of these? We're just refreshing our memory as to the statement of the problem. On this slide, we have our original setup Let us draw lines that join points to their images and see if they cross each other. That one to its image and that one to its image. Notice that they do not cross. They do not cross. We are therefore sure that the transformation cannot be a size transformation with negative scale factor, because in every transformation or size transformation by a negative scale factor, lines joining points and their images will cross each other. In the right angle triangle, what is the value of tan theta? The angle that we are focusing on is theta. That one. To find any trig ratio of theta, we need to name the sides relative to it. The hypotenuse is the longest side and is opposite to the right angle. Irrespective of where theta is, the hypotenuse is the same. The side opposite to it, which is theta, facing or on the other side of theta, is said to be opposite. The side that is beside, alongside, or adjacent to theta is said to be the adjacent of theta. Tan theta is equal to opposite over adjacent. Opposite is 5, adjacent is 12. The correct answer is option B. In triangle ABC, angle A is x degrees and angle B is 2x degrees. What is the size of angle C? So we have the three angles. A is known to be x degrees and B is known to be 2x degrees. An illustrative diagram will be deliberately left out of this problem. It is simple enough for mental images only. The sum of all angles in a triangle is equal to 180 degrees. Therefore, when we add A, B and C, the result is 180 degrees. Substitute A is x degrees and B is 2x degrees. So 2x plus x is 3x. Or we may do the transposition first. Transposing the expression, making C the subject, we have C is equal to 180 minus x minus 2x. X plus 2x is equal to 3x. Therefore, subtracting x and 2x is the same as subtracting 3x. So C is equal to 180 degrees minus 3x degrees, or 180 minus 3x degrees. The correct answer is therefore option C. The diagram shows the angle of depression of a point X from Z. If X is 10 meters from Y, the height YZ in meters is what we are attempting to find. The trig ratio usually associated with angles of elevation and depression is tangent. Based on that fact, we may conclude that the correct answer is option B. So as long as we are talking about angle of elevation and depression, usually the trig ratio associated with that is tangent. So we may capitalize on that fact. However, we may solve the problem actually to verify that we are correct. And it is not safe to conclude that since we are talking about angles of elevation and depression, that the trig ratio is tan. That is not a safe thing at all. It is not impossible to design a problem with angles of elevation and depression, yet still tangent is not the trig ratio that is applicable. So we are sure that we may go to the extreme Or we may be a little bit innovative in constructing a problem in which the trig ratio in an angle of elevation and depression problem is not tangent. So it is better for us to play it safe and go through the process. We know that angles of elevation and depression are alternate, or we call them colloquially Z angles, and are therefore equal. So those two are equal. They are alternate angles. The height of YZ in meters is what we are attempting to find. The side YZ that we need to know is opposite to the known angle. The known side is adjacent to the known angle. The trig ratio that contains opposite and adjacent is tangent. Therefore, we are correct and we need not go anymore. But making a substitution, opposite is YZ and XY is 10. Transpose the equation by multiplying by 10. On the right hand side, we have YZ is equal to 10 tan 30, and we have verified that B is correct. So it is not good to make the assumption that because one thing always follow another, that one is the cause of the other. It is not good to assume that because we always use tangent in an angle of elevation and depression problem, that every single one of them must make use of the tangent trig ratio. That is what we call causal generalization, and that is not a sound argument at all. We have verified that the correct answer is actually option B.